welcome back. We're going to be looking at reflex action, or what you can still call involuntary action. Reflex action, or what you can call involuntary action. What is a reflex action? I can define it as, you can pause the video and try and see if you can define it. Okay, but look at this. I can define it as a reflex action. A reflex action is an involuntary action of the body that responds to stimulus automatically without the control of will. Stop. A reflex action is an involuntary action of the body that responds to stimulus automatically without the control of will. That's what it is. It is a system or an action that you respond without thinking. That means the brain is not involved at the first stage of this response. What is involved in this response is the spinal cord. It is under the unconsciousness of the body. I'll give an example of reflex action. One dipping hand in the hot water did not need to think twice before withdrawing the hand from it. This is a reflex action because it's involuntary. You do not think before the hand is removed from the hot water. Or someone coming with an object close to your eye to pluck your eye out, you must, without thinking, blink your eye. So blinking of eye is an example of involuntary action. You don't need to think before you blink eye. And anytime you can't stay without blinking eye, you must blink eye. You cannot say keep your eye without blinking it, because these actions are involuntary actions. These are the actions that are within the control of the spinal cord, not within the control of the body entirely. So these are the things we're going to be discussing under the reflex action. All kind of involuntary actions are reflex action. So that's why I say it is automatic. So the activities of reflex action is being controlled under the peripheral nervous system called the word autonomic nervous system. The word autonomic means automatic. So the body automatically switches over and responds very fast, very quick to such responses. You can see that the responses are too fast, but before the responses are achieved, information are passed to and fro to the spinal cord before coming back to the effector, where those effects are being exerted on the response, the targets, what they call the target organ. We're going to be looking at a structure of a simple reflex action. Simple reflex action. A simple reflex action. Okay? I will begin with the diagram of the spinal cord. Spinal cord. Very simple to draw spinal cord. Spinal cord is just a H structure, H shape structure. Look at it. Look at this. It is made up of two regions. This region is the first region I just drew now, which has a central canal. This is the white portion of the spinal cord. And we have the gray portion of the spinal cord. Look at the gray portion of the spinal cord. This second layer now is the gray portion of the spinal cord. So I can label what I have already. What is this? This is the gray portion, so I can call here gray. Gray matter. Gray matter. And here is what? White matter. White matter. And here, central canal. Central canal. This is where you see your cerebrospinal fluid in the central canal. Okay. Let's see how impulses from this divide, because this whole of this place is still part of our central nervous system. So let's see how impulses can get through the spinal cord, which is part of the central nervous system. Okay, such a simple reflex action. So I would like to begin here with these aspects here. Okay, this is a finger, and this finger is punctured by a pin. This is pin, and what happened? There is pain. You feel pain because you have pain receptors in the skin, and equally there is a pressure. There's a pressure. This is the function of the skin. The skin is sensitive to pain, pressure, and temperature. But this has nothing to do with temperature, so it has something to do with pains as well as pressure. Now, like I told you before, there are some nerve endings here. Nerve endings, okay, that is moving, that is going to convert these pains, all these pains, pressure, will be converted as impulse. And these impulses are now within this neuron, which will move the impulse straight to the spinal cord. But the gray matter extends with cell body out. Same thing here, it extends. Okay. Now, this neuron that has converted these pains and pressure into impulse, taking them from these parts, from this P.N.S. to the C.N.S., is called what? The sensory neuron is doing that. The sensory neuron, okay? So impulses, look at it, impulses are moving, and they first of all move through, they will first get to the white matter and now descend into this matter. This one is the gray matter. So this is the sensory neuron, but there is what we call this is the ganglia. The ganglia cells, okay? This route through which the sensory neuron move impulses to the CNS, this route is called the dorsal roots. So impulses are leaving this particular receptor to the CNS through the back door of the spinal cord. The back door of the spinal cord is called the dorsal view. Okay, there's a neuron that is stationed in the CNS, and that neuron is called the interneuron. Look at the interneuron here. Interneuron. The interneuron, look at it here. So I'll label it interneuron. Interneuron. Okay. Now the interneuron ensures that the sensory neuron coming from the dorsal roots does not mix or meet with the motor neuron leaving through the ventral roots. Okay. Because this divide, since here is the dorsal roots, this side is the front side called the ventral roots. So the ventral roots, where you're gonna have the motor neuron. Look at the motor neuron. Is now moving the impulses. If you follow these roots, so this is a neuron moving impulses away from the CNS, and the name of the neuron is called the motor neuron. Motor neuron. So the motor neuron is moving these impulses straight to the muscles, the hand, where it happens. Because the muscle here, the bicep muscle and the tricep muscle, one must relax, the other one will contract before you can withdraw your hand from where it happens. So the motor neuron, once the impulses jump, it will jump, this will connect the impulses to this one, it enters the motor neuron, which brings such impulses back to the muscles. Okay, look at the muscles here. Look at the muscles. Look at the bones. The muscles. So which means this hand is withdrawn as soon as these impulses from here, from motor are brought. So this is what happens. This is an effector gland. This particular effector we are dealing with is the muscle. So this reflex action is a reflex. Arc. Okay, what is a reflex arc? A reflex arc is just a pathway through which a reflex action is achieved. Okay, the pathway that has happened here, what we have here, is just a pathway of reflex action that is between the muscles and the CNS. Is a pathway, so you call this a reflex arc. So to achieve a reflex action, it is done through a reflex arc. The pathway through which the reflex action is achieved is called what? The reflex arc. So take note. Most important thing you must know here that the impulses moving away from the P.N.S. to the CNS, for example, the sensory neuron is moving impulses away from the P.N.S. to the spinal cord, but it gets the spinal cord through the backside, through the dorsal view, the backside. It got here to the CNS. It enters through the spinal cord from the dorsal view, from the white gray matter into the white matter. Then the interneuron is interrelating or connecting the neurons, because I told that one neuron begins from the P.N.S. and terminates at the CNS, another neuron begins from the CNS and terminates to the what? P.N.S. The neuron that begins from the CNS to the P.N.S. is the motor neuron. But the impulses must jump across this space. The space in between two neurons, the two gaps, is called what? The synapse. So impulses must synapse or jump one particular gap, and the impulses are carried by another neuron, which is motor, which move these impulses through the ventral or front side of the spinal cord into the muscles, where the hand is quickly withdrawn from the pin. So this is a very fast response of the body. A fast response of the body as in response to danger like this. So thank you for watching this video. You can click on the subscription button for more videos. Thank you.